to store time series data of the neural activity from these sessions. So we're gonna say that in these sessions, we took neural data, time series data, and so we have to store them. We'll store them inside this table that we're gonna create. Now, the time series data here are stored in NumPy files, and they're stored using a certain naming convention that denotes the name of the animal as well as the session date. So these files that we're gonna import, that we're gonna store, they follow this naming convention. So they're stored inside the data folder. And so in the first, so here the name of each file is data underscore, it will be mouse ID and session date. So for example, if the mouse ID was 0 and the session date was the 15th of June 2021, those would be the values that would be in here. So what we're gonna do now is we're gonna just choose one mouse and one session, and we'll see how we can import data. So let's say that we wanted, we're curious to know what happened with mouse 0 on June 15. So of course we call our query. And so now let's say, so we only want the key. So we have the same exact query here, and we only want to fetch the key. So we've seen this before, and we'll assign that to key. So now that we have the key, we remember that the key gives us the primary attributes of a table. And if you'll recall, the key for the session table, the primary attributes for the session table were mouse ID and date of birth, and mouse ID and session date, sorry. And these are the these two fields right here. So if you're not as familiar with Python, Python has the ability to do what's called dictionary unpacking. And so we know that our key has this data for mouse ID and session date. And so we can format, using the .format method, we can format this string using this dictionary. So our file name was dynamically updated using the information from the key. So now we have our file name, which is data_data_2021-06-15.numpy. Excellent. So now that we have our file name, let's load this data. Let's see what it's like. And so our data is in the form of an array. And you can see it here. So this is all the data from the neural trace. Now let's look at the shape of the data. And so we get a 1 by 1,000. It is a 1 by 1,000. And so what this tells us is that in this particular session, we collected the data for one neuron, or we got the data for one neuron here, and we got 1,000 different data points for that neuron within that session. So now that we have our data imported, it's loaded, we'll take a little sec from there, and now it's time to define this table, this automated table. So of course, we have our at schema. We say, hey, DataJoint, I want you to insert a table inside schema. And we'll call this table neuron. Now, if you recall, the previous two tables, mouse and session, had a manual right here inside as is. So it had dj.manual, denoting that it was a manual table. You type in the data manually. But for this table, we will use DJ. And once again, like I said, we have the best team in the world. Thank you to Tim, Kabi, or DevOps, Chris, Drew. Thank you to everyone. And so yeah, so we left off defining our neuron table. And we said that unlike the other two tables, which are DJ.manual tables, which you'll be putting data into manually, the DJ will use the DJ.imported. And this means that the data is going to be automatically imported or taken from an external file source and placed into the table. So as we define the architecture of this table, we see the arrow and the session. And this means that the neuron table is going to have a dependency on the session. And if we were, as we can recall, we know that whenever a table has a dependency on another, it imports it uses the same primary attributes. So session was dependent on mouse, right? And it used its primary attributes. So in neuron, we're going to have the mouse ID, and we're going to have session date, right, as its primary attributes. Another primary attribute that we're defining here is neuron ID. So when we looked at our data up here, we saw that the shape was a 1 by 1,000. And as Tin had said earlier, this means that, and as I had said earlier as well, this means that this is the data for one neuron, 1,000 different points from the activity trace for one neuron, right? So if there were multiple neurons, then, so this table is telling us that it can accommodate multiple neurons for the same session, right? Multiple neurons, yes. For our secondary key, we'll have activity. And we haven't seen this quite yet, but we define activity as a long blob so that it can store a NumPy array holding the electric activity over time. This NumPy array will be imported from the file corresponding to each folder. So as we had said earlier, the data from our sessions are stored inside these .npy files or these NumPy files. Yes. So let's define our table. And we look at it, and beautiful. So as we said, the primary attributes from session and implicitly from mouse are here. So mouse ID, session date, and we also have neuron ID, and we have activity being our secondary attribute. Let's look at our schema. Now our pipeline is really taking shape. It's looking good. Just as a quick aside, we can see that the mouse and session are inside these green rectangles. And that is a visual way for DataJoint to tell us these are manual tables. And we can see that neuron is inside this blue oval. And that tells us that neuron is an imported table. Another quick aside, the diagram, also, if you hover over the table, you can also see that you get more information about the columns inside the table. So basically the column names. So now that we've defined neuron, and now that we've seen our data, let's import, right? But before we do, so the way to import data into a table is by calling the populate method, okay? So we know that neuron is an imported table. So let's call it. And we see that DataJoint complains, right? Said subclasses of autopopulate must implement the method make. So basically what's happening here is DataJoint is telling us, hey, you want me to import data, but you didn't tell me how to import it. You didn't tell me where to get it from. You didn't tell me if I should do anything to the data. You didn't tell me anything, right? So I can't populate this data. And so the way we tell DataJoint and the way we specify how to import this data or how to populate the data is by defining what's called the make function. And so the make function, we can see it takes a single argument, which is key. We have self, of course, which tells this function to look at itself, right? The neuron table. And key refers to the primary keys that are inside this table. So we know that our primary keys are mouse ID, session date, and neuron ID, right? So, and all we're gonna do for this make function right now is we're gonna print key is, and we're gonna import each key, or each row for each key. So now we've defined it, and now let's run our .populate. And technically it's not importing data, it's just printing. And so it's telling us key is, and it's giving us the keys, right? So mouse ID 0, session date, right? Mouse ID 1, mouse ID 2, mouse ID 3. Awesome. So when we call the populate method and an imported table, and this is very important, this triggers DataJoint to look up all the tables that the imported table depends on. And for every unique combination of entries in the dependent or parent table, DataJoint calls the make function, passing the primary key of the parents. So we could see that mouse ID and session date are in the parent tables. And so those are what were printed. Yes, as a note, note, the make only receives the primary attributes of session, right? In this case, mouse ID and session date, but not those secondary attributes, not those other attributes. So let's see what we have inside neuron now. And we still don't have any data because all our make function did was print, right? So now we're gonna redefine our make function. And this time we're gonna tell DataJoint, and we're gonna specify what data to get, how to get it, and we're gonna specify all these instructions. So this part we've seen a few times. And so we're gonna focus on the make function. So we can see that it's longer now. And so we're gonna go through it line by line. So the first line that we have here is the data file. And we've seen this already, right? When we spoke about dictionary unpacking. And so we're telling DataJoint that whenever you call the populate method, it wants you, well, right now we're just gonna define the file. So we're saying that each data file goes by this naming convention, right? Next, we're gonna load the data, right? And finally, we're telling DataJoint that for index and for IDX, or for index and D in enumerate data. So for those of us who are familiar with Python, this is a fairly common start of a for loop. For those of us who aren't, the enumerate function, what it does is it gives you the position and like the data. So in this case, enumerate data. So if you have, let's say, 5 data entries, so the enumerate function would have data entry 1. The first data entry would be 0, then the second would be 1. So it'd be like, it would create a tuple of 0 data, 1 data, 2 data, right? So it just enumerates it. So for index and D in enumerate data, and we're gonna use this column, neuron ID, and we're gonna, so neuron ID is gonna be the index of that data. And the activity here the data that's going to be imported in is going to be the data itself. So let me say that again. So inside our make function, we're telling the neuron table to go look for files that are formatted this way inside the data folder. We're going to load the data, and then we're going to enumerate the data. And inside the neuron ID column, we're going to put the index, because we're just going to follow the convention that the index of that data was the number of the neuron, or the ID of the neuron. And then the activity is going to be the data that was paired with its index. And finally, we're going to insert this data. We're going to use self.insert, and we're going to insert the data. And finally, we're going to insert the key, sorry. And finally, we're going to print populated neuron of neuron ID for mouse ID on the session date using our, we've seen this method. So we're going to print the data. We're going to print the fact that we imported some data. So right now we'll take one last look at our table before we run the populate. Now we're going to populate. And we can see here that we've populated neuron 0, right? For mouse ID 0 on this session date. We've populated neuron 0 for mouse ID 1 on the session date. So what it's telling us is that all the data files that we had, they were probably in that same, the data shape was probably that 1 by 1,000, because it seems that there are only one neuron per session. And so we've populated all the data for each of those sessions. So now we look at our data, and we see that neuron has been populated. So for mouse ID on this session for neuron 0, the first neuron, we get this blob, right? Which is that array. So the blob is, scroll up here. The blob is this, right? All this data. And that's how we import data into a table. So what happens if we call neuron.populate again? What do we think is going to happen if we call it again? All right, so I'm sure we're all thinking about it, probably not sure. So let's call it again and see. So we called it again, and since there were no new sessions, nothing happened, right? These were all the sessions that we inserted with their data. And so there's no new data right now. And so everything that's needed to be populated has been populated. But what happens if we try to insert a new entry into session? So we're going to insert some data into session for a valid mouse and a valid session date. So we'll insert some data there. And just to check, just to make sure that it's there, we're going to select all session entries without a corresponding neuron, or a corresponding entry in neuron. So we see that this session that we just entered is there inside session, but it doesn't have a corresponding entry inside neuron. So we're gonna imagine that Tim did a great job documenting and putting his data in the right place. And so now we'll call a populate, another populate. And so it tells us that it's populated neuron 0 for mouse ID 34 on this session date. And as Kavi had said earlier, this is where a lot of the power inside DataJoint lies, because this process becomes automated, right? So you can run like a cron job. And basically, you have a script where after you're done for the day, you have this script run this neuron.populate, and it automatically fills in the data downstream for you. So we look at neuron once more, and we see that we have our final field right here, or final entry right here. Awesome. So in summary, congratulations, you have learned about DataJoint workflows. You've created your first workflow. You've interacted with this workflow. So we've queried, we've fetched data from a database, and we've used DataJoint to automate computation. I cannot leave us without pointing us into all these links. So if you want to, please, we would love for you to join the DataJoint community. You can access us via any of these links, datajoint.com. We have a great website if you want to chat with us. We have a Slack. If you are a current researcher and you would love to use DataJoint inside your experiment, of course, reach out to us. If you, as Kabi was talking about earlier, we have what's called DataJoint elements. And we're always developing new elements, so new workflows. And if you would love to be one of those early adopters for a novel workflow, you can reach out to us here. And if you want to learn more about our open source tools, please reach out to us via this link. So I want to thank you guys for just for all your time, patience, especially with our technical difficulties. I want to thank our team here at DataJoint. Thank you all. And I hope you guys took away quite a bit from this presentation. So if we have any questions, we can ask those right now. Thank you, Tim. Appreciate it. Let me check.
All right, great. If there's no question, I think thanks again, David. We can
thank you. Here. All right. So I'm thinking, should we just leave the breakout room?